Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight it's pre-calculus. We're going to look at some of those distance formulas and try to get them into our head just a little bit better and work just two problems. And but the way all of these work out, if you can get these right, I think you can be well on your way. All right, let's get after it here. We have 2 points. Point A is at -3, -3. Point B is at some value x. We don't know what that is. That's what we have to solve for. And the y value of 5. Okay? But the distance between those 2 points, we have 2 points here, A and B. So that's A, this is B, we'll say. That distance is 10. What should x be in order to give you 10? Well, we know the distance formula is y, let's go with x first. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and the square root of that sum. Okay, let's see. Why don't we let this be x sub 1, y sub 1, x sub 2, y sub 2. Let's do that. Okay, so that would mean, as a matter of fact, before I put those in there, let me just go through and let's solve for x sub 1. So this would be our value we're trying to solve for. Well, okay, if I square both sides, I can wipe out that radical sign. Okay, I got rid of that. Now then, let me subtract this from both sides. So I would have d squared minus y sub 2 minus y sub 1 squared. Okay, and that wiped it out right here. Got rid of that. Okay, and that equals x sub 2 minus x sub 1 squared. So I was just left with that. Okay. I've kind of annihilated that one. Well, what do I do now? If I take the square root again of both sides, I just wiped it out so I could manipulate this a little bit. If I take the square root of both sides, well, actually that squared symbol goes away. The square root of that square wipes it out. So now I have this. And remember, we were looking for x sub 1, so we're trying to get this guy. So if I add x sub 1 to both sides, well, okay, if I add x sub 1 to both sides, let me put x sub 1 over here, plus x sub 1, wipes that out. Then subtract that from both sides. So it gives me x sub 2 minus all of this. I'm trying to save board space and I don't think I'm accomplishing that. Okay, so x sub 1 equals all of that. So now we've manipulated this thing, the distance formula, to get to this point. Okay, now x sub 1 equals x sub 2, which is a -3. So -3 minus the square root of d squared, which is 100. So 10 squared, 100, minus y sub 2, which is a -3, minus y sub 1, which is 5, and that squared. Okay? So x sub 1 equals -3 minus the square root of 100 minus, okay, a -3 minus a positive is plus a negative. So that is -8 squared is what that would be. -8 squared is a positive 64. So it's minus a positive 64. So that gives me x sub 1 equals -3 minus the square root of 36. So square root of 36 is 6. So x sub 1 is Negative 3 minus a positive is plus a negative, so that equals negative 9. Okay, so let's check ourselves though. So it should be, if I put negative 9, 5, I should be able to calculate the distance using the two endpoints, because now I have negative 3, and I have negative 9, 5. Well, obviously that's over here. Negative 9, I didn't know that when I started. Okay, so we're this way. All right, so having said that, I can find out if I work through that distance and it comes out to be 10. So let's try that. Okay. Distance equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And the square root of that sum, distance equals square root of x sub 2, negative 3 minus x sub 1, which is negative 9, plus y sub 2, which is negative 3, minus y sub 1, which is 5, and that squared. Okay, so what do we have here? Negative 3 minus a negative is plus a positive. So that would be plus a positive 9, so that would be a positive 6. Oh, and that's squared, sorry. Squared plus negative 3 minus a positive is plus a negative, so that gives me a negative 8, same as we had earlier, and that would be negative 8 squared would be 64. 6 squared is 36. 36 plus 64 is 100. Square root of 100 is 10. So my distance equals 10, and that's exactly what we should have come out with. Okay. All right. Yeah, I wish I'd have known that was negative 9, 5. I would have put my point over here somewhere. Okay, but you get the idea. We had no clue where that was, and we figured it out. Good deal. All right, I'm going to pause the video and clean this up and write down the next problem. Okay, we've got a second problem here, and sorry for pausing, I'm just trying to keep the videos from getting too long. Okay, we have 2 points that are defined. We have point A, it's negative 1, 2, and then we have point B, which is 3, x equals 3, y equals 0. And they have some point out here. Only thing we know about that point is it's x equals 5. We don't know the y value k, but they want us to figure out what the value of k would be such that this distance from A, we'll call this C out here, from A to C is the same as B to C. Okay, so what does that mean? That means the segment AB equals, I'm sorry, not AB, AC equals BC. So AC equals BC. So AC equals BC. Now if we were doing this in graphic school, we would just take our, when we'd stretch an arc out here of the same distance and another arc out here at the point of intersection, that would be our point. It would be, it would be that simple. So it'd take you about 5 seconds. There it is. And then we just measure it. Okay, but we can't do that here. We've got to calculate what it is. All right, just know there are other ways. Okay, so the distance formula then for AC, let's do that one. It's saying that, it's the, any distance is equal to, and we just worked this a minute ago, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and the square root of that sum, that gives us that distance. Well, we can still do that even though we only have k. And let's just work along. A lot of times in math, you think, oh, I don't know how to do that. Well, just keep grinding away at it, because you can't eat the elephant all in one bite. You have to nibble along on the ear, the different parts, until you slowly eat the elephant. Same with math. Go at it. Maybe that doesn't work. Back up. What went wrong? Okay. Go at it again. Same here. So all I'm going to do is write the distance formula for this segment and then set it equal to the distance formula of the other segment and solve for k. There's going to be a k in both of them. We'll just solve for it. Okay. We'll see if I get to the end and have a all right, x sub 2. We're going to let this guy over here, this will be x sub 2, y sub 2, x sub 1, y sub 1. Sometimes I do that just so I can keep it straight. There's no reason for that, because you're squaring the numbers, you're getting the relative distance between them, so it really doesn't matter, but just for the sake of consistency. Okay, so I have x sub 2, which is 5, 5 minus x sub 1, which is minus 1, that squared, plus y sub 2, which is k, minus y sub 1, which is 2, and that squared. Well, that equals, let's see, well, this was AC, that's AC. Now we'll put this one as BC. So BC equals what? X sub 2, which is 5, minus x sub 1, which is 3, squared, plus y sub 2, which is k, minus y sub 1, which is 0, squared. Okay? Minus the negatives plus the positives, so that's 6. 6 squared is 36. So I have 36 plus k minus 2 squared. Well, let's just go ahead and FOIL this thing out. First times first, k squared, minus 2k, that's minus 4k, plus 4. Okay, so I have plus k squared minus 4k plus 4. Have all of that in there. We'll see if I needed to do that here in a minute. All right. 5 minus 3 is 2. 2 squared is 4. Plus k minus 0 is k. K squared is k squared. Okay, you'll notice I have a radical sign on both sides. Well, if I just square both sides, that radical sign goes away. So I have 36 plus k squared minus 4k plus 4 equals 4 plus k squared. Okay, well, let me subtract 4 from both sides. Those wipe out. If I subtract k squared from both sides, whoo, man, we're rolling now. So that equals 0. So what do I have? 36 minus 4k equals 0. So add 4k to both sides. 36, you know, if I add 4k, that one cancels. 36 equals 4k. Divide 4 on both sides, so 9 equals k. Oh, but not yet. We don't know that that's correct. What to do? Well, I tell you what. Let's put our 9 back inside here. Put our 9 in there and just see if those two are equal. So 5 minus this gave me 6 squared, and all this under radical sign, plus 9 minus 2, which is 7 squared. So that's 36 plus 49, 36, 49, 85. So we have, that equals the square root of 85. on that side. I don't know what square root of 85 is, but if I get another square root of 85 on this side, we're good to go. All right, so what do we have? We have 5 minus 3 is 2, 2 squared is 4, and then k was 9. Whoa, 9 minus 0 is 9. 9 squared is 81. 81 plus 4 is 85, so we have the square root of 85. So k equal 9 was a solution. So we would have the 0.59. At least this time I'm in the correct direction. Okay, now. Okay. All right, this was just a few examples of how to use the distance formula sometimes when you're given partial coordinates, you could calculate what they are. So, all right, more to follow after this. Why are we doing this? So that together we can build a better tomorrow. And don't forget what I said about give a kid a book. Okay, pick a subject that the child needs a book. Give them a book. Help them out in school. Okay. All right, that's enough for now, and we'll talk to you next time. Thanks.